Hi everybody, welcome to the video notes 1.1 for the introduction to Java programming. On this video note we're going to have an introduction to the Java technologies. The objectives of these video notes is describe how Java compares with other object-oriented programming languages like C++ and C#, and basically we're going to just make a comparison with how the other languages handle syntaxes, platform independence, execution speed, and memory management. We also are going to describe some of the most common use of Java applications. We're going to review how Java compiles and interprets code, and understand how bytecodes let Java achieve the goal of platform independence. So let's go start this revision by looking a little bit about the history of Java. Java was first introduced in 1996, and again the main premises of the Sun guys was that it was a programming language that would allow developers to write applications independent of the platform where they were when they were supposed to be executed. So the Java Development Kit 1.0 was introduced in January 1996. Subsequent improvements to the JDK were introduced in 1997, 1998, 1999. And in December of 1999 was introduced the first version of the Enterprise Edition. So the previous versions were JDKs or were just kind of not really targeting the enterprise market, but it was called JDKs. Then in 1999 we kind of have a division between the standard edition that was released in August, and then the Enterprise Edition was released in December. Since that date, pretty much every time we have a new JDK, the Enterprise version is also updated, because the Enterprise rely on the use of some of the classes that are part of the standard edition. We're right now in version 6, standard edition version 6, that was released in December of 2006. And yeah, it's been 4 years, and we're now on revision 20. So from the December 2006 edition, we have 20 revisions, and that's the one we're going to be installing in this class. So now let's go make a basic comparison of Java with other object-oriented programming languages. Let's go first start by comparing with C++, maybe the preferred language for software developers before Java. So basically what the Java guys decided to do is just, okay, there's a base of developers, and most of them are developing C or C++, so let's go use a syntaxes like C or C++. So that's why we said that Java syntax is similar to the C++ syntaxes. From the execution perspective, basically here's where Java made the big promise. Okay, you're gonna write code that we're gonna give you a programming language where basically you just need to program once and you can run everywhere. The main problem of C++ is that the compiler is strongly tied to the platform, not only the operating system but also the CPU. So pretty much when we talk about platform will be the combination of a CPU or a microprocessor and operating system. So every time we write a code for Windows 95, if we want to run that code on Windows XP or Windows 7, as you may know if you're a Windows user, that code won't run, right? The reason for that is because the compiler will be associated with a specific platform. And again, the promise of Java was, okay, no matter if you write it for 95, okay, then if you move to XP, you should be able to run the same application. Obviously, we have different releases, and we have new releases where some problems are fixed, some classes are deprecated, so that could also happen, right? We are in a constant change, and Java code is constantly being updated, so that's important to notice as well. Sorry guys, let me just go. I need to do something here. Okay, so let's go back here. Speed, because C++ is compiled into binary code, so it's supposed to run faster than Java code. That is what is called compiled just in time. And then memory management, I think that's their big tool for developers. And basically in C++ applications, developers need to manually manage memory, while in Java application, most of the memory management is done by the JVM of the Java virtual machine. How does Java compare with C#? C# is a .NET language from Microsoft. In this case, the Microsoft guys said, okay, we have a bunch of C++ developers and Java developers, so it really doesn't have any sense to have a new set of syntactical rules. So let's go with Java or C++ syntaxes. From the execution perspective, C# is also a framework-based language. So that means that there's some sort of platform independence, but that independence is only between Windows environments. Some people have tried to work on a version of the framework for Linux environment, and there's certain applications that will run in these framework versions for Linux or Unix environments. I cannot confirm that C# runs faster than Java, but that's what I found in some books and some blogs on internet. And from the memory management perspective, the memory management in C# is also done by the framework of the Java runtime, the common language runtime is called in Microsoft, and most of them is automatically. From the kind of applications that we can write on Java, we have Java applications that are meant to run on a desktop. These applications can be console-based or can be Windows-based. Again, from the Windows-based application is really cool because you can develop these applications running on a Windows environment, and you can take the same application and go run it in a Macintosh environment, and they should work seamlessly. Then, for web, so we have a special type of application called applet. An applet, it's a specific object of Java technologies that you can include into an HTML page. So you're noticing here that the address bar just pointed to an index.html, and that class, that plugin for the Java applets would allow to some processing to be done on the client. So in this case, this Java applet will run on the customer side, on the client side. There's another type of object called the Java servlet. Servlets are slightly different than applets, and basically, as you're noticing here, we don't have an HTML resource. So a servlet it's a class that runs on the server, and that class will take care of rendering the HTML code. So this servlet, feature value servlet, will take care of rendering these HTML tags in there. There's not an HTML5 per se, but this server will take care of everything. Okay, now that we know those applications, let's go see how Java solved the mystery of platform independence. So what we do, we just write classes and we use a text editor or some of the IDEs. In this case, we're going to be using NetBeans. When we have our class, we store it in a file, and that's the source code with extension of Java. Then we'll use the compiler for that specific platform, and the compiler will generate what is called bytecodes, Java bytecodes. And it's just a binary file that it cannot be interpreted by the operating system, but can be interpreted by the Java virtual machine. So when we need to execute it, with the Java virtual machine will take that bytecode, we compile it just in time, but the just in time compiler into binary code that the operating system can interpret, and it's going to give it to the operating system for execution. And here we have just a list of what you described. I hope you enjoyed these video notes, and see you in the next one. Bye guys.